bird in the tree. So as we read through these, we're going to kind of visualize kind of real world situations here. So you got this person here. We can make this look like a tree if we really wanted to. We're going to ultimately draw in it as a triangle. But if you have this guy here and he's looking at, the bird in the tree, and we start talking about the angle of elevation in which he is looking up, then you are talking about the angle created as he looks up, along with the flat surface that he is standing along. All right, so that's our angle of elevation. So it's basically the angle in which we look up at something. We also have what is called the angle of depression. Similar to the one that we just did. Obviously, it's going to be something different. So this is a different name here. It's still going to be the angle. It's still going to be formed by the horizontal as the observer looks downwards. So now this is dealing with the idea that if I have somebody standing up here, they're still going to be looking straight out. That's kind of our basic assumption, that if we are looking straight out, it's going to look like this. So it's still made with the horizontal line up here at the top, but also now as we look downwards. So if this is the horizontal and this is us looking downwards, then the angle of depression would be this angle right here. All right. So when we come over here, same idea. If we are standing here and we are looking outwards horizontally, so it's made with the horizontal line, and then the angle that's made as we look downwards. So as we look down here, it is made by those two segments. So this is our angle of depression. Okay. The big thing about the angle of depression, when we look at this, old idea, something we haven't had to do now in a couple of chapters, a couple of modules. When we look at this horizontal line right here, and we look at this horizontal line right here, it's understood, I think everybody here would agree, that horizontal lines are parallel to each other. Okay, they'll never touch. So remember how we talked about parallel lines, and then we would have something called a transversal? The transversal is what intersects those two parallel lines. So in this instance, this is your transversal. So the big thing with these problems when we start doing those angles of depression, this is definitely the angle of depression right here. However, do we remember what this angle and this angle would be? We had all those sets of angles. Armando? Good. Aren't these alternate interior angles? They're on opposite sides of the transversal, but they're inside the parallel lines. And then all of those little properties are either supplementary or congruent. Alternate interior angles were what? Do you remember that part, Armando? Congruent. So what that means is a lot of the problems, not a lot of them, all of them, when you were told that you're given an angle of depression, so let's say our angle of depression was 40 degrees. That's not working so good. If we know that this angle is 40 degrees, then since it's alternate interior, we know this angle is also 40 degrees because alternate interior angles are congruent. So that's going to be a big thing here. Whatever this angle is, so we'll call this angle X. That means the alternate interior angle down here that's actually inside of the triangle would also be the angle X. All right. So those are our basic definitions. We'll do enough to where that will not be a problem after the first couple. All right, but now jump down to the word problems, and then we're just basically going to be setting these up. So your directions are set up and then solve the following problems. We definitely want to draw the diagram in, and then we're going to continue to round to the second decimal place, the 100th spot, okay? So number one, it says the angle of elevation. So that means we're going to be looking upwards from a point that is 49 meters away from the base of a flagpole to the top of the flagpole is 27 degrees. So as we read through that, that just set up a right triangle for us. So what we're going to do with this is we're going to start by drawing in a flagpole. So if I drew in a flagpole right here, we'll make a little ball at the top. You don't just have to be an artist with this, but this is your flagpole. Then a point that is 49 meters away from the flagpole. So I'm going to put that over here. So there is a point here. Here is the base of the flagpole. That's the bottom of your flagpole. This point, you are told, is 49 meters away from the base of that flagpole. So we know that's our 49. You can start to see the triangle form here, okay? And then you are told the new word or new definition, angle of elevation from this point to the top of the flagpole. So here's the horizontal. Here is what we're looking up towards. So the angle of elevation is talking about this angle right here. And you were told that that person is looking up at a 27-degree angle to the top of the flagpole. And then now the question is find the height of the flagpole. So if I were to put like an X here and a Y here, which of those variables is the height of the flagpole, Armando? Y. So we are solving for this. So this is what you did 20 times yesterday. That whole worksheet was here's this triangle, set up, sine, cosine, or tangent, whichever one is appropriate, and then solve that. All we're doing today is we have to come up with the diagram ourselves. So if we now look, so let's erase the X, we're not concerned about that. If this is our angle, and this is the height that we are looking for, and this is the side that you were given to work with, we should all now be pretty good with these if that assignment went pretty well. We were somewhat understanding that well yesterday walking around. Still dealing with this. Let me write this one more time for today. Still dealing with this idea. If this is our angle, the height of this is what? The adjacent, the opposite, or the hypotenuse? Joel, what is this? Good. So this is our opposite. All right. And then Ella, what is this side? Good. That is our adjacent side. So if we're talking opposite and adjacent, we are setting up a tangent function here. So you're going to say the tangent of that 27-degree angle is equal to the opposite side, which was the Y, over the adjacent side, which was the 49. It's one of the three types of equations that we had yesterday, so we still got to understand how to solve that. Actually, do that real quick. This is what you did a bunch yesterday. So solve that. Make sure we got this down. Answer that. All right, and Julia, what'd you get for that? Good, 24.97. We do want to put units on these now that we're talking about things tangible, all right, distance, angle, so on and so forth. This is the height of the flagpole. The unit that they were giving you here is meters, so it would be about 25 meters tall, okay? To solve that, just make sure you understood that. We just multiply by the 49. It gets rid of this, and if we do that on one side, you've got to do it on the other. All right, and then that's our answer. So the only difference is we got to be able to read through these carefully. Some are easier than others, set up our own triangle, and then it's just what you did a bunch yesterday. All right. All right, so 22. You were told that a 15-foot ladder is leaning against the house and makes a 52-degree angle with the ground. All right, so again, you can be real graphic with this, not terribly important, but you have to understand if this is our house, the ladder is leaning against the house. So if this is your ladder here, it's leaning against your house, that's what we're going to assign the 15 feet to, the ladder leaning against the house. So the L would have been right here. That's 15 feet. As it leans against the house, it's going to make a 52-degree angle with the ground. So here is our ladder, and then here is our ground. So the ladder and the ground will make a 52-degree angle. So that's this guy. And then the question is asking you, how far will the top of the ladder be above the ground? So let me again give you two variables because now we don't know this side, we don't know that side. If I am asking you how far will the top of the ladder be above the ground, what are we looking for, the X or the Y? Well, so here's our top of the ladder right here, right? Do you agree with that? And I want to know how far will the top of the ladder be above the ground? Isn't our ground then right here? So we're looking for how far this guy is above the ground. So we are looking for that X. Okay. All right. So if we can draw a decent picture and we know what side or angle you're going to be looking for, this is what I'm hoping we're pretty efficient at. Spent a couple of days doing it. Big long assignment yesterday on it. Set this up. See if we know which trig function we are using. All right, when we set this guy up, Omar, what trig function do we need to use if this is our angle and these are the two sides you're given to work with? Good. That is the sine. This is the opposite side. This is the hypotenuse. So that's why you said the sine. It's the sine of a 52-degree angle. The opposite side is the x. The hypotenuse is 15. Okay. This is the same type of equation that you just solved in number 1. So far, we've only encountered one of the versions that you would have saw yesterday. Multiply that out. And what'd you get, Omar? Did you do it? 11.82. Good. 11.82. This is getting measured in feet. So the ladder would be about 11.82 feet above the ground. Okay. All right. 3. All right. So as an airplane takes off at an angle of elevation of 21 degrees. So obviously an airplane, okay, we'll abbreviate. Here's our airplane. Initially it's on the runway. All right. It's on the horizontal. So it's running flat on the ground, but eventually it's obviously going to start to take flight. And as it does that, the angle of elevation, once it gets off the ground as it starts flying up, is 21 degrees. All right, so that's where we're going to place that angle. And then it says, if the plane travels 10 miles during this initial ascent, how far off the ground will the plane be? So again, we're forming a right triangle here. So let's go ahead. At some point, the plane is right here. We're going to drop this down. This one's a little sneakier. The 10 miles is how far the plane actually would have traveled. All right. This is your plane right here, correct? It's the thing that's going up at that angle. So when we assign this 10 miles, we're talking about the 10 miles during his ascent. So it's actually how far the plane traveled. So the 10 needs to go right here. All right. If it said the horizontal distance was 10, we would put it right there. All right. So real quick, I'll have you try the next one completely on your own. Maybe if it's a nice one. Well, maybe not. But identify, what are we looking for? Are we looking for this side or this side? Because you have to understand what the question is asking for. There's 2 missing sides, and through the words, we need to know which one we're looking for. Assign that your variable. And then once you've assigned the variable to the one you're looking for, set up either a sine, a cosine, or a tangent equation based off of that. Yeah. All right, that before we get too far here down the path of solving it, if they're not quite correct. So let's try this again. I'm going to call this x. I'm going to call that y. Those are the 2 sides that we are missing. The question is asking how high off the ground will the plane be. So I'm going to go back to Mo here now, Mo. What do you think this time? We're looking for the x or the y? Good. Here's our plane. Here's the ground. We're looking for how far off the ground that would be. So I'm going to erase that one. So you're dealing with this angle, these 2 sides. So the trig function that we would want to use is this is our angle, and those guys, Lily would be what? Good. It's the opposite side. It's the hypotenuse, so we're setting up a sine. So the sine of that 21-degree angle equals the opposite side over the hypotenuse. Multiply that 10 over. And then whatever that gives us is our answer. All right, did you get that, Lily? What'd you get? Good. Should get 3.58, and then our distance is getting measured in miles. So a little over 3.5 miles in the air. Okay. All right. Number 4. Go number 4. The first angle of depression problem. Probably a little trickier to graph, especially this first one. So just read it carefully, understand what it's given you. It says, from a 60-foot observation tower on the coast, there is a Coast Guard officer that sights a boat that is in trouble. As soon as you see the words angle of depression, that now tells us we're actually looking down for the first time. So the guy's on top of the tower, he's looking down, and when he looks down, he sees a boat off in the water. The angle he is looking down at is 3 degrees. Okay, So first thing I'm going to draw in is a little tower. You can just draw a line if you wanted, but here's our tower. We got a guy hanging out up here, kind of looking at everything. What we know is it's a 60-foot observation tower. So we're going to assign 60 feet to that length there. He's off the coast, so here's our water. There is a boat in the water. So there's my beautiful boat. And then as he is looking down, when he sees this boat, his angle of depression is 3 degrees. So this is where you need to be careful. These are the ones that tend to cause the more issues. The 3 degrees is always created with the horizontal line and then the angle that we either look up or down. So if this guy up here is looking out straight out horizontally, he would be looking here. So the horizontal is here, and the angle he is looking down at the boat is right here. The angle that is formed by those two is right in here. So that is our angle of depression. Now, is that angle even in the triangle that we just formed right here? No. So that angle there doesn't do us a whole lot of good because it's not even within the triangle, but it's what we talked about when we first set these up. This is a horizontal line that would be parallel to this horizontal line. So this angle here and this angle here are alternate interior angles, and we know those have to be congruent. Okay? So we know this angle. We know the height of the tower over here. The question is now asking for how far is the boat from the shoreline. So again, let me assign a couple of variables. We're missing this side of the triangle. We'll call that one X. We're missing this side of the triangle. We'll call that Y. If we are looking for how far the boat is from the shoreline, what are we solving for, the X or the Y? Nick or Tyler. Good. It is solving for the Y. Here's the shoreline where the tower would be. Here's our boat. So we are solving for that angle right there. All right. So when we now set this one up, if this is our angle, we know the opposite side. We are looking for the adjacent side. So the opposite and the adjacent is a tangent. So we will say the tangent of that angle is equal to 60 feet divided by Y. So for the first time today, now we have one of the different versions that you had to solve yesterday. So if I now ask you to solve this, we don't want that Y in the denominator. So this is the version where you would have multiplied by the Y to get it out of the denominator. So then you're just left with the 60 on the right. If I do it to one side, I've got to do it to the other. So I'm going to multiply by Y right there. So in the next step, we would have Y times the tangent of 3. And again, I'm assuming we did these. You would divide that by the tangent of 3, and then whatever that gives us should be that answer. Okay. Flip this. No, don't flip that yet. And that should give you, and this is going to be measured in feet. All right, that's the unit that's in play here. So this should be 1,144.86 feet. Okay, I'm getting that. All right, and then that's our answer. Okay, I'm going to have you try to set this one up. I'm going to do one little thing here. This is a little ambiguous. There's a little information here that we're not going to use. Don't worry about this person being 6 feet tall. Let's just pretend that's not there. So cross out that little tidbit and see if we can go all the way through this one. Can we come up with our own graph? Can we identify what side you're going to be looking for, what angle you're going to be looking for? And then can you solve the equation that you would then have set up? All right, so now from all the way from A to Z, see if we can get this one done. person standing there, just erase the fact that he's 6 feet tall. So we still have this guy here. Right. Again, I would read this really carefully. Okay, not bad. All right. So we have this person here. For the most part, we're doing okay. There's a couple people that we want to kind of check this. There's a person standing 132 feet away from the tower. So you have to understand, if this is now your tower, him standing 132 feet should be this length right here. All right, and this is obviously the tower. You were then told the angle of elevation from that person to the top of the tower. So from the person to the top of the tower is 25 degrees. And then we were looking for the height of the tower. So if I want to figure out how tall is the tower, are we looking for the X or are we looking for this Y in relationship to mine? Ben, what are we looking for? Good. We are looking for this length right here. All right. We don't want the hypotenuse. So to solve for that one, what function did you use, Ben? Good. It's the tangent of 25 degrees because we know the opposite side is the Y and the adjacent side is 132. Okay. And this is probably the easiest of all the equations that we deal with to solve. You're going to multiply by 132. And what'd you get, Ben? 61.55. Good. 61.55. And then this is feet. Okay. All right. What I want you to do next, jump to number 10. We're going to try to do the ones that are all very similar with not quite having a full period today. Go to number 10, set number 10 up. See if we can do that one. A little trickier, but very much in line with the ones that we've been doing. We can visualize this, see who our artists are. Number 10. Go to number 10, number 10, number 10. The others are a little bit different. We're a little short today with time, so let's keep with these. It's got a nice screen. Read it really carefully. It's 50-50 who has the shadow in the right place at this point. Think about where a shadow lies if you're outside. So if you're standing outside and you've got the sun, and I ask you, where's your shadow at? Where are you going to see your shadow? Okay. Yeah, the actual shadow itself. This is the third equation, the first time we've had to do it today. Once you have it set up, so you can remember how to solve it on the calculator. This is one that people tend to have a harder time with as well, solving. All right. Let's see if we have it set up right, because a lot of people do not. Okay, so let's check this first. I'll draw a tree. A lot of people are drawing the tree, so that's wonderful. So here is our tree, and then overall, we know that this tree is 18 feet tall. So nobody really had any issue with that. Everybody had that assigned to the correct place. Then the tree is going to cast a shadow of 25 feet. So I left this side available. So we'll say that the sun was over here, so that our shadow is over here. As I kind of walked around the room, this is where some people had this assigned wrong. Think about where you see your shadow if you are outside in the sun. All right, isn't your shadow on the ground when we see it? So when it says the shadow is 25 feet, the shadow is right here. This is where you would be underneath the shade of that tree out of the sun. All right, so the sun is in here. So as we do this, our right triangle would then be formed like that. The question then is, know what angle we're looking for is what is the angle of elevation of the sun? So the angle that we are then looking for is, if I am right here and I wanted to look up at the sun, this is the angle here that we are trying to find. That is the X that we are trying to solve for. All right. If you got that on your own, that's pretty good. First time we've talked about kind of the shadow question. It's kind of a classic little SOHCAHTOA question with these little word problems. This is your setup. If you did, then my guess is we can set this up good. And then it's just a matter of remembering how to solve this equation. This is our little SOHCAHTOA idea. This is the opposite side. This is the adjacent side. So you should have set up a tangent. And you're going to do the tangent of the angle is equal to that opposite side over 25. This is now us trying to solve this for X. All right, anybody confident in what we're supposed to get here? What should this angle have been, Omar?
35.75 feet.
Good. And how did you plug that in? Not feet in this case, actually. Because this is our angle. Angles are measured in degrees. So it's about a 36-degree angle. What did you plug into your calculator, Omar?
Second tangent, 18 over 20.
Good. If we are trying to get rid of that tangent, this is when you do the second tangent key, and then you do the second tangent of 18 over 25. So this is when we go to our calculator, do a second tangent of 18 divided by 25. That's what you enter into the calculator. When you do that, it should give you that 35.75 degree angle. Okay. All right. I'm going to give you this, but then listen carefully here because short periods. What did I do with this? Okay. So give me. All right, when you get this, so write this down so you don't do more than what I want you to do. So when you get this homework, I'm going to have you do 1 through 12. However, you're going to skip number 6. Okay, so when you get that, mark that so you're not trying to do problems we haven't necessarily done yet, especially 14, 15, and 16. So those, let's see how we do on those little word problems there. And then if we have any questions on it, we can talk about it tomorrow. We will have a quiz on Thursday over all the SOHCAHTOA stuff. So the little word problems, what you did yesterday, setting them up. Nothing new tomorrow. What's that?
Thursday?
Today's Wednesday.
Yeah.
What did I say?
You said quiz Thursday.
Oh, Friday. So tomorrow we'll kind of, if we need more time with these, we'll do a little review of it all, and then the quiz, on Friday. Okay. So by then, have a calculator that works. You're not going to be able to use your phone on that quiz. Okay. Although it is, I think it's 38. Okay. Either way, we don't. Yeah. Stop recording.